Hello class, this is another video for Math 141. Trying something new, so I hope that you'll be able to see the screen and understand what I'm saying a little bit clearer here, and that the picture won't be so shaky because I'm not holding the camera. This is chapter 11, and we are starting the lesson on probability. So this first slide tells you the first topic that we are starting with, the fundamental counting principle. And if you've never heard of the fundamental counting principle, it probably sounds just what it is, sounds like just what it is. We will be counting things. See, it won't be so bad, right? So the definition is if you can choose one item from a group of m items and a second item from a group of n items, then the total number of two item choices is m times n. So there's an example here, and we've all done this before in a sense. We're looking for an outfit. We want to choose a pair of pants and a top. And so in this case, we want to know how many possible combinations of those different pairs of pants and those different tops will we have. So in this example, we have two different pairs of pants, black and blue, and we have three choices of distinct tops. It looks like pink and yellow and blue. And so how many different outfits can we have from these choices? We can have 6. 2 times 3 is 6. On the right side, there is an example of a tree diagram where we're able to show those different outfits, beginning with the different types of pants and then matching these shirts with each distinct pants. So applying the fundamental counting principle is, again, pretty easy. In this example, we have the Greasy Spoon restaurant offers 6 appetizers and 4 main courses. In how many ways can a person order a 2-course meal? Well, we know that there are 6 appetizers and 4 main courses, so we multiply the 2 to get the answer. Now we'll modify the fundamental counting principle to include more than just 2 groups. So in this example, again, we are looking to find the total number of outcomes in choosing an outfit. So in this example, we have, again, 2 distinct pairs of pants, 3 distinct shirts, and now we have introduced 2 pairs of shoes. Of course, we need shoes to walk out of the house, so it would make sense to include that into the outfit. And right now it's cold, so we probably should have a hat in there too, right? So we have 2 pants, 2 shoes, and 3 shirts. So in order to find the total number of outfits, combining each of those elements should be 12 distinct outfits. In this example, we have students who are creating their course schedules. And so you are planning to take 3 courses, math, English, and humanities. So there are 8 sections of math, 5 of English, and 4 of humanities that you find suitable. Assuming no scheduling conflicts, how many different 3-course schedules are possible? So again, same idea. If we have 8 choices for math, 5 choices for English, 4 choices for humanities, we can multiply those 3 to find 160 different 3-course schedules. Okay, in this example, we have a multiple choice test. So you're going to take a multiple choice test that has 10 questions, but for each question, there are 4 answer choices with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, which you shouldn't do anyway, right? And how many ways can you answer the questions? So for question 1, question 2, question 3, all the way to question 10, there are 4 choices for each. So if you choose an answer for each question, there are 4 different ways to choose for each one. So 4 times itself to the 10th power. So there will be 1,048,576. That's a lot, right? The number of ways you can answer the question is over 1 million ways. In this example, we have telephone numbers. So this is one that I learned when I was learning this. It's a pretty popular question. So we have telephone numbers in the United States with 3-digit area codes, followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with 0 or 1. So we're starting to exclude digits. So a question you probably would ask yourself is, how many digits would you have remaining if you excluded those 2 digits? Hopefully your answer is 8. So how many different telephone numbers are possible? So again, we need to know how many digits we'll be working with. Typically, there are 10 digits, not typically, but there are 10 digits that we use in our number system from 0 to 9. But since we cannot use 0 or 1 for the first digit in the area code and the local number, in this first slot, you see that we have excluded. We have excluded the first 2 digits. So we only have 8 digits to choose from. But the other 2, there are 10. So in the area code, we know we have 3 digits that we can use. And so the first, we can have a possibility of 8, and the other 2, 10. And the local number, something similar. The first digit, again, we exclude 0 and 1. And then the rest, we have a possibility of a possible 10 digits to choose from. And so if I want to know the number of different telephone numbers possible, then I multiply all of those numbers together, and that again is quite a few, over 6 billion. And that is 11.1.